Good morning, good afternoon, good evening. It is phenomenal to get to be here with y'all. I'm excited. My name is Whitney, or Whit. I go by both. I am a GMAT, GRE, and executive assessment instructor at Manhattan Prep, and I am super excited to be with y'all today to talk about data sufficiency, two-part, and like a really kind of unique question type within those, the logic problem. But before we get started, I would love to hear about y'all. So join me in the chat. Where are you coming to me from? So first quick question. I'd love to get a little bit of familiarity from y'all. Like, where are you in your studies for the GMAT? So we're going to be working on two of the question types that are within the data section, the data insight section of the GMAT. And so I do want to make sure that, we're all kind of comfortable a little bit with what the GMAT looks like. Well, I'll go over just kind of briefly a little bit about the test, and then so you can kind of see what we're working on, like where we are. But my goal for us today is we're going to focus in on the data insight section, and we're going to look at two specific question types. So we're going to look at data sufficiency, and we'll look at the world of two-part questions. And both of these are part of what's known as the data insights section of the test. Now, in this realm, we are going to look predominantly at logic-based data sufficiency and these two-part. So what I mean by logic-based is that these are really neither verbal nor quantitative, right? And so the DI section, the data insight section, kind of comes in three flavors. The information that we'll be getting can often feel real world, but sometimes it feels more contrived. And so in those cases, it's going to feel more like maybe a math problem. So in data sufficiency and in two-part, we'll sometimes get very, quant section typical questions. They might also be a bit verbally. And so especially in two-part, we might get questions that feel a little bit more like critical reasoning with arguments. But then there's this weird third type. And so if anyone's ever taken like an old LSAT, or if you ever used to play like old puzzle word logic games, there used to be this magazine, I think it's actually still a magazine, called Games. And it was packed full of like weird crossword puzzles and word finders and organization puzzles. It's that kind of world that we're dealing with. So when we look at logic-based, we're going to be looking today at arranging games. So we'll be given some constraints or some rules about a scenario, and those rules will kind of limit the number of total possible ways that an event could play out. And so our job is going to be thinking about how to visualize these logic-based problems so that we can draw some inferences, draw some conclusions from them. These turn up in data sufficiency and in two-part. So we'll start with data sufficiency. And so it sounds like a lot of you have already worked with the quant section, and you've already kind of worked with some of this material, and maybe you're just getting started on DI. So data sufficiency may not be the most comfortable for you yet. So I'm just going to take a moment to make sure that you understand how data sufficiency works. But then we're going to jump into a real problem. So the way data sufficiency works is that you'll be given some upfront information at the top. We often call this the question stem. And then you get two statements, right? So we're going to call these statements. And they'll be labeled in most explanations, either with our materials, official materials, or any other company you work with, as statement 1 and statement 2. Okay. And so I say this, I highlight this as something quite important because the answer choices for data sufficiency will always look like this. So I want you to take a moment, kind of scan these answer choices and get you a little thought about, okay, so then what does data sufficiency test? So one of the things I want you to notice here is that data sufficiency is not testing a value or an answer, right? My answer choices A through E don't have a value next to them. right? There's no real number just sitting there. And so it's not testing what the answer to the question is, it's testing whether we can get an answer to our question. And so we'll be given upfront information that will include a question that we are seeking to answer. And then those statements will give us some information that will hopefully be helpful in doing that. Now, I like to think of data sufficiency a little bit as like a normal question in reverse. Normally, in a math problem or a verbal problem, you get all of your knowledge up front and then they ask you a question, asking you to synthesize it. This is sort of backwards. You get the question first, and then you're given whatever information you might need to answer that question. Now, the information that they give you not be complete. And so you may notice that in some cases, like E, using statement one, statement two, even all of it together is not enough. I still can't answer my question. So we want to think of this a little bit like I'm a researcher. I've got this question, I need to answer it. I'm going to look at each statement to try and determine, is the information presented enough? Is it going to give enough information to answer my question? Yeah. So let's go ahead and give this one a try. Yeah. So I'll go ahead and give it to y'all completely. And then we're just going to try it, see how it goes. We'll walk through it more step by step together, but we'll give it a shot. Yeah. All right. So here you are. Generally speaking, we have about 2 minutes per question. I think that that's usually not enough time for DI questions. And so I'm often trying to find a couple of questions in the section that I don't have to work on. And so I can spend an extra 30 or 40 seconds on questions. But today I'll let you spend about 2.5 minutes, 3 minutes, especially with this first one, because you're just trying it out. Yeah. So enjoy. And then we'll take a look at it together. And beautiful. When you think you've got it, we've still got about a minute left, so continue to work if you'd like. But when you think you've got your answer, go ahead and send it to me through the chat window. I'd love to see how we're doing. And the other thing I'd love to hear for those of you submitting answers, maybe tell me a little bit about what you did to solve. So, did you draw something? Was there a visual? Did you just kind of think through it? How'd you keep yourself organized? All right, that's about 240 on my side. And so, again, we'll go ahead and take a look. My general rule of thumb is when I'm studying individual questions, I set a timer that counts up, and I'm going to take however long it takes to try and do the problem. I want to learn what my natural timing is. I want to make sure that I'm not rushing through things, right? And so I only really use timers that generally count down when I'm doing timed sets of questions. So I'm trying to practice balancing my time. So just keep that in mind that as you're getting used to these new question types like data sufficiency and maybe even the two-part, I think two-part is a little less tricky to get your head wrapped around. But as you're getting used to the question type itself, you might want to spend a little bit of time just like giving yourself more time for these questions. Yeah. Okay. So, first thing we need to think about is how we recognize that we're in a logic based question. Because I love how many of you said visual chart. I drew out some slots, right? I made a small chart, a way of visualizing it. When it comes to these logic based problems, a visual representation is almost always going to be your best move because the solution is going to involve kind of an ordering. And notice that this question tends to sound a bit more overt in its ordering. Like they're talking about having 3 meetings that have to happen in a specific order, first, second, and third. And then a little bit of information around where each person is allowed to fit. And so I love how folks were saying a visual chart. The 3 slots is honestly my kind of way to go. Yeah. So let's cover up our answer choices for a second and just sort of think about, right, this like upfront piece. I've got 3 people, I've got 3 meetings. How do I want to organize that information? It might be nice to organize it like, okay, I've got 1, 2, 3 people, right? These 3 folks. And each meeting, it starts at 1 and then it's going to end at 4:30. Right. And so I might think about when each meeting would start. So these are going to be 1 hour long meetings. So this will be a meeting from like 1 to 2. This meeting would start at 2:15 and go to 3:15. And then this meeting will go from 3:30 to 4:30. So we've got like 3 meeting slots. So in fact, just go with that, right? Let's go ahead and say, all right, we'll just do 1, 2, 3 slots with 1 p.m., 2:15, and 3:30. So maybe something that looks a little bit like that. Maybe it's a little messy, but something that looks a little bit like that. And then what I'll do is start to assess my 2 statements. So now before we do, I often take a moment to look at my 2 statements and see if one of them seems easier than the other. Right? So if one of my statements seems a little bit easier than the other, then that's usually the one I'm going to start with. In this case, it certainly would seem like the first or the second statement, excuse me, a little nicer. It's a little bit friendlier than the first statement. The first statement has a whole lot more information. And so it might be nice for me to work in that statement first. So I'll make us a little bit of room and we'll get both of our statements on the screen. Now, the key though is here we go. And then we'll make a little bit more space with these. We'll get our statements up on the screen. And then we'll talk about what to do with our answer choices. So I've got my 3 spots, my 1 p.m., my 2:15, and my whatchamacallit, 3:30 meeting. And we're trying to figure out, did Cassie meet with Fatima last? And typically in these types of problems, a single letter for each kind of agent is plenty. So I'll get us our 2 statements online. Let's get our 2 statements up here so we can see them. Here we go. So we've got our statement 1 and our statement 2. Statement 2 definitely seems a whole lot more simplistic. So maybe that's where we start. Now, we have a kind of method at MPrep that we call the T diagram or the T chart. And so what this is going to look like is generally the more generic form of it, if you're like wanting to see just sort of more spaced out what it looks like. The generic form of this is going to look as follows. Up top is going to be any info from the question. It might be like facts and tables and work that you put together. And then eventually you're going to put somewhere, the question. Then you'll do your work for statement 1 on the left, always. Your work for statement 2 on the right, always. So no matter which statement you start with, you always know that 1 is on the left and 2 is on the right. And then if you need to, like I don't have an answer yet, I'm going to bring my 2 statements together and work on them at the bottom, because it's a little nicer to bring information together when they're kind of on even footing with each other. Yeah. So in our little kind of T diagram here, we'll start with statement 1 and 2 separately. Let's start with statement 2, right? So my question here is, in this schedule, did Cassie meet with Fatima last? Okay. Well, I know that Cassie met with Natasha first that afternoon. And so if we've got our 3 slots, Natasha went first. Now, that doesn't tell us exactly where Fatima and Seth go. So what I have to do is, if I can't perfectly map out an order based on the information given, I'm going to need to then test scenarios. So it could be that Natasha was first, and then Fatima, and then Seth. Or it could have been Natasha, Seth, and then Fatima. Once I've got my various cases, what I'm actively looking for is to see if I can answer the question in different ways. Because if we think back to our answer choices from before, right? Those are statements. Then what we've got in those answer choices is this, just kind of like bring us back there for a second, right? We're trying to figure out if each statement alone is enough to give us an answer. If the information from the statement doesn't let us land on a single answer, then it's not sufficient. What we're trying to do is show whether we can get different answers, because if I can get different answers, I can prove that something is not sufficient. Yeah. So in this space, in case 1, right, I've got a scenario where it is Fatima last. No, Fatima is not last. That would answer the question no. The second statement, is Fatima last? The answer is yes, because this fact, this Natasha fact, results in 2 different answers to the question. It is not sufficient. Okay, there's a little mnemonic I want us to practice. So statement 2 is not sufficient. So let's come back to this for a second. So we'll grab our statements. Oops, there we go. I'll get our statements out of the way, or our text out of the way. Let me move some stuff so we can see. Okay, so if statement number 2 is not sufficient, then what answer choices would I eliminate? So if statement 2 is not sufficient, what answer choices do I eliminate? Yeah. So I'm going to eliminate anything that says that statement 2 is sufficient. So I'm going to eliminate answer choices B and D. So it's going to leave me with A, C, and E. Okay, I can do that. I can do A, C, and E. All right, so let's go take a look then at our statement 1. Okay. So as of 2:20, Cassie had yet to interact with Seth. Well, if Cassie hadn't interacted with Seth by 2:20, that would mean that Seth can't have been her 1 p.m. or her 2 p.m. meeting. And so Seth must be her last meeting. Now, that doesn't tell me where Natasha and Fatima are. Again, Natasha and Fatima could be first and second, or Fatima could have been first and Natasha could be second. Now I have multiple scenarios. I'm going to go look to see, okay, how does this answer my question? Did Cassie meet with Fatima last? In my first case, the answer is no. In my second case, the answer is still no. Now, be careful. We might see no and think not sufficient, but in fact, we're getting the exact same answer, which means we're getting an answer to the question. So we have this belief that no is maybe the answer we don't want. But what if somebody said to me, or what if I asked the question, do I have to work this weekend? If you told me no, I'd be really happy, right? If I asked, do I have to pay that fine? And you said no, I'd be really happy. So no is just as great of an answer as yes. We don't care which one we're going to get. The fact is that no here is sufficient. And so if statement 1 is sufficient, when statement 2 is not, that means our correct answer is A. Something to note about C. We only test answer choice C only if neither statement alone is sufficient, meaning that I cannot get an answer from either statement individually. Okay, so we are not going to test it out. Not going to test it out. Yeah, we're not going to test it out if we can get an answer from either statement. You want to let me know which part of it more specifically? Yeah, for statement 1. Sure. So note that statement 1, if Cassie hasn't interacted with Seth that day, when does Cassie have to meet with Seth? Right? She hasn't interacted with Seth by 20. When must her meeting with Seth be? And I'll kind of ask the crowd, like, do I have that right in my schedule that her meeting had to be at 3:30? So kind. But so notice if Cassie had yet to interact with Seth by 2:15. Right. So notice if Seth is in the middle, what time would that meeting have started? What time would that meeting have started if she met with Seth in the middle? Right. So when is my second meeting start? Great question. Yeah. So if my second meeting starts at 2:15 and Cassie has not interacted with Seth until as of 2:20, she hasn't seen Seth. That means that Seth can't be her 2:15 meeting. Yeah. Because it says if each meeting started and ended on time, meaning that whoever showed up to the 2:15 meeting got there on time. And so if Seth hasn't laid eyes on Cassie hasn't laid eyes on Seth as of 2:20, that means that Seth can't have been her 1 o'clock or her 2:15. It must be the case that Seth is her 3:30. So could Cassie have been her 3, or could Fatima have been the 3:30 if Seth was the 3? No. Not possible. All right, how are we feeling? I would love to get a sort of comfort level because the next one we're gonna step up the next one a little bit. Just for be warned, the next one is a little more challenging. More than anything, I want to make sure that you're comfortable with data sufficiency, right? That you understand the format of the question. So here's my poll for you. Um, 1 being the least comfortable, 5 being the most comfortable. How do we feel about data sufficiency? Okay, so 1 the least comfortable, 5 the most comfortable. It's okay. I don't expect 5s if I'm being really honest. But if you're like 3 and up, I feel pretty good. I feel like okay. Amazing. Yeah, amazing. Again, not necessarily that you're going to get all data sufficiency questions right, but that you understand this idea of sufficient. Killer. Okay. Let's do a second one then. Yeah. So, like I said, a little bit more challenging. I want to invite you to actually spend some time thinking and sketching it out. I'll put 3 minutes on the clock on my side. Again, I want you to have enough time to kind of play with this. It's more than we'd want to spend maybe on this on the real exam or a little on the long end, but that's okay. Yeah. So give this one a shot and then we'll talk about it together. Okay. I'm starting to get some answers in. That was 3 minutes on my end. Definitely a harder question, right? For sure, harder question. Round always makes a problem for me because it's like, oh god, gosh, what do I do with round? But we got this, I promise. We got this. Okay, so one thing I'd like to do before we start the solution And I appreciate all the like, I think it's this, but I'm pretty unsure. Totally okay. One of the things I'd like to start is just sort of a look at our answer choices. And so there's a really nice mnemonic kind of floating around for kind of an easier way to memorize our answer choices. And it's this concept of 12-10. So 12-10 stands for answer choice A, B, C, D, and E. 1 alone, 2 alone. I need to use them together, either alone or nothing. Like nothing is enough, right? No matter what information I throw at this silly thing, I can't get an answer. And so 12-10 can be a nice little way of kind of memorizing your answer choices. You could always write just like 12-10 down on your paper. Definitely come hang out with us for more data sufficiency because we have other techniques you can use that are elimination. But for today, since we're just doing this one more, 12-10 is enough. We'll use it for our process of elimination. Okay, so let's take a look. I've sort of split things up into the beginnings of like a T-chart, and I've tossed a 12-10 down here for us so that we can use it. I'll sort of stick it over here out of the way. But I've got to come up with a way to visualize this problem. I've got these people. Often their letters will be A, B, C, D, E, F, or PQ, right? T, U, V, W, X, Y, or something, which is really nice. Rarely will they have people have the same letters. So they're trying to make things nice for you. It's like a puzzle. And so I've got people sitting around a table, and I've got one fact given. One. So let me first build my table. So I've got, I just want to see what these folks would look like. All right. So I've got 1, 2, 3, 4, 5, 6. Yeah. And with these 6 folks, and maybe I'll kind of move this thing out of the way a little bit because it's a little high. I'm going to plant somebody in one place. So let me get this guy out. And so here we go. I've got a little circle. I can just keep reusing everywhere. Here's what I know. I know that Amal and Bob don't sit next to each other, but that's like an infinite number of places where they could sit if they're not sitting next to each other. I want to know if they're sitting across from each other. So what I need to do is pin one of them. And so I don't know if I'm going to pin Amal or Bob. I'm going to take a quick scan of my statements. Statement 1 doesn't mention either of them. So, but statement 2 does mention Amal. So I'm going to go ahead and pin Amal since Amal ever gets mentioned again. I'm going to pin Amal up here at the top. And then I'm going to make a note that Bob can't sit next to him. And so then I'm going to throw another one of these circles down. And I'm going to ask my little question. So here's my little question. Is Amal across from Bob? Is that the orientation of my little people? Well, in this case, statement 1 seems a little bit more simplistic, right? So maybe I'll go with statement 1 to start. Sure, why not, right? So I'll just kind of toss them over here. All right. So I'll leave them all in here. I'll stick them all back on top. And now I got to figure out where Casey goes. And Casey sits neither next to this D person nor across from them. Okay, so I'm going to put Casey here. And if Casey can't have Deo across from them, right, directly across, or here, so this one can't be Deo, this one can't be Deo, this one can't be Bob, Deo has to be one of these two. So it could either be, well, and actually I'll leave Bob off for a second. According to just this statement, if these two can't be Deo, Deo either goes here or here. So now I need to think of my 2 scenarios, right? Or think of however many scenarios I can come up with. And what I'm really looking for here are scenarios that give me different answers, right? So again, we're back in this universe of wanting different answers. And so let's say we put Deo here. And then Bob is going to go right here because that works, right? We've got, we've got Amal hanging out wherever. We've got Casey sitting next to Amal. And we can move things around, but we've got Casey sitting next to Amal. And we've got one scenario where Casey sits neither next to Deo nor directly across from Deo. Yep. And if I put Deo here and Bob goes here, then how do I answer the question? Do they sit directly across from each other? The answer is yes. Well, is there another variation of this? Is there another variation of this one that would work, right? Can I try another variation? And so if I do the same kind of circle again, so if I get I'll put my Amal back in and I'll kind of re-sketch it with my factoids. So we may need to take some room and get statement 2 out of the way a little bit. So if this is Casey, it's not Deo, that's not Deo. If I put Deo here, that would stick Bob there, and that's not allowed. Right? Bob's not allowed to go there. So if Casey sits right here, I'm going to kind of wiggle these off my paper. Casey sits right there, there's only one option. Bob has to sit across. Now, quick question. Would it give me a different set of answers if I put Casey here? So to Amal's left instead of Amal's right. Is that going to change anything? Do you think? No. And the beauty of the circle, like the pain of the circle is it can be a pain to start to think about like, well, wait, where does everything go? But the beauty of the circle is that in some ways, repeated values don't matter. Right? They're not going to matter to us. So one of the things we can do is just kind of take some of those options and say, okay, if I put C directly next to Amal, doesn't really matter. So what's the next option? Let's put C down at an angle from Amal. So we'll put C here. And I know that I can't put Deo in either of these places or directly across. So Deo has to go here. I'm not allowed then to put Bob in either of these places. So Bob has to go here. I've got another yes answer. Holy moly. Okay, so I'm getting another scenario. I've moved Casey, but I've got yet another scenario where moving Casey hasn't changed anything. We don't. Right, so we've got C, we've moved to a situation now where C would be, in fact, not next to A. Yeah, so we were just picking an option. That's all. I wasn't assuming that they had to. I was just trying to pick one. So I still haven't been able to move Bob, right? So I'll kind of move these out of the way. I still have not been able to move Bob from across from Amal. So let's try one more. There's only one more scenario. Like, can I put Casey across from Amal? Like, could Casey be my one who's across from Amal? So I'll get one more of my little circles up and let's try. Get this out of the way. Here we go. Okay. So let's get Casey and put her directly across from Amal. Okay. So if I put Casey right here, then I can't put Deo directly across nor directly next to Casey. So Deo's going to have to go in one of these. But it turns out I could put Bob like over here. So I finally got a no answer. Finally, right? I finally have achieved my no answer. And so because I've got two different responses, let me refresh this so it pops back up. Because I've gotten two different responses, yes and no, statement 1 I can now prove that it is not sufficient. So if statement 1 is not sufficient, what answer choices do I eliminate? Mhm. Yeah, beautiful. I'm going to get rid of A and D, or one alone, or either is enough. So I'm going to get rid of those two. Now I'm down to B, C, and E. Cool. So let's take a look. We'll go with our Amal chart again. I'm just pinning them all at the top because why not? Right. So we'll pin them all at the top. And here's what I know. Ella cannot sit next to Amal, nor can she sit directly across from Amal. So let me make a little line so that we can sort of see more clearly the difference between them. Okay, so Ella can't sit next to Amal. So Ella can't sit in either of these two spots, nor can Ella sit directly across from Amal. So I'm going to stick Ella in one of these two spots. Turns out that Ella also can't sit next to Philippe or directly across from Philippe. And so if this can't be Philippe and this can't be Philippe and this can't be Philippe, then this one has to be Philippe. If I try to put Bob up here, I'm not allowed, right? No Bobs up in those. And so the only place I am allowed to put Bob is in the bottom. Any flipping, right? Sort of the same as this first scenario here. I don't have any option, right? I can't, I have to put Bob at the bottom. I can't put him up in the corner. And so I've only got one scenario that works. I could move Ella to the other one, but it would just be the mirror image of this. Because of that, I get an answer of yes, Bob does in fact sit directly across from Amal. And so if statement 2 is sufficient, my correct answer is B. So it turns out, right, like just because there are multiple orders, because I never placed, Casey in this second one. Casey never went anywhere. Deo never went anywhere in the second one. So I have like other options for those two. But in this question, I just needed to prove that Bob was sort of stuck, right? Bob was stuck where he was. Okay. All right. So how are we feeling about logic? Because we're going to switch over to logic in two-part, but it's going to have a very similar feel. It just won't have this same restriction about like, how do I use statement 1 versus statement 2? In the upcoming questions, it'll just be use all the information, but we have to get two different answers. So instead of having two statements, it's two answers. Okay. All right. For this next question type, for the two parts, what's going to happen is that we'll be given, and so I'm given it the generic version of what it looks like. We'll be given some upfront information, and these are called two parts because they have like a two-part table at the bottom. And so we'll be given at the top, we'll get some upfront information. That'll be the factoid stuff that we're going to use. Then we'll get instructions with the question itself. And the question will always basically have two parts. This will be question 1, and this will be question 2. And for this, you're going to pick one answer in each column. Okay, so be careful. It can be easy for people to think this is like one answer per row, but each column is like a multiple choice question. These 5 or 6 answer choices are your choices for question 1, and they're the same choices for question 2. Okay, give this one a go. And again, I'll give you about 3 minutes.